Good afternoon, ladies and gentlemen. It doesn't, you won't say SIP, but SIP, we would call this. And I belong to Mitsubishi Electric Corporation as well. And whenever I talk, in which capacity are you talking? That's the question I get asked. So I like to put on those two double hats again to talk about this. And in the KDRN organization, we had a lot of discussions. And when you consider Japanese projects, they have not been actually put into practice. I complained to the government that you're wasting taxpayers' money. But then there is a silo organization that is hindering that. So the Cabinet Office is taking the lead to organize these types of projects. And I said that would be fine. That sounds great. Then I was asked to actually head the project in the Cabinet Office. And that's why I'm wearing this double hat. Now, I'd like to talk about the target market first. Well, rather than the government officials explaining about this, the person who's from the private sector should explain about this. So I'd like to put on the Mitsubishi's hat to explain about this. So let me first explain about the history. It all started 10 years ago. And back in 10 years ago, some of you may be aware or remember, but there was a buzzword, a smart grid, back then. And it was dispatched by the government to Albuquerque, and there was such a fuss about this back then. But what we found was that there are three key issues. The storage factory cost need to be reduced to 1/10, and you also have to enhance the velocity, and you have to also solve the optimization issue. And then there was somebody who said that the quantum computer could be used. So this smart grid program, Mitsubishi has a plant in Amagasaki, and they were making advertisement. But if we are asked what happened to that, it's be difficult to answer. And target was clarified, and to what extent we should do to call the smart grid. But in order to further reduce the cost, you have to attract attention to invite finance. And then came up with 3D printing. Obama administration back then launched 3D printing project, and the Industry 4.0 came out, and now more recently there's the Industry 5.0, but we do have Society 5.0, and we're catching up with Germany for Industry 4.0, and I was in Germany 2 weeks ago, and now Germany is at Industry 5.0, and 10 years ago we were talking about Society 5.0 in Japan, and people in Germany now said that now they understood what we were talking about 10 years ago. And we're not making public relations activities enough. And now we started work on smart one, and then semiconductor attracted attention because it is necessary to do anything. And once we came to the issue of semiconductor, there's U.S.-China trade friction, and to China, the latest semiconductor technology or exposure device cannot be exported to China. So U.S. companies are monopolizing the market, and with the digitalization. But then European players are now confronting that. And so in the computation, the quantum computing, maybe last year or 2 years ago, emerged all of a sudden. And so we have focused our target on this to put this program up. Now, from a bit different perspective, let me talk about accelerated market creation. The smart manufacturing, or DX, in Japan. Well, those of you who are from the US may not understand what DX means, but for the past 5 years, in under pandemic, the plant was operational to the full capacity, and then the pandemic set in. But the plants that are operational even under pandemic, and those that are not during the pandemic, and those who are operational had this digital transformation already completed. And then the smart factory is now the one that everybody is shifting to. And what accelerated this more is that in order to increase the number of smart factories, then you have to get vehicles involved. That's what they realized. And then came out electric vehicles, EVs. And with regard to electric vehicles, I was talking to the people in the public sector, and is it EV, is it going to contribute to decarbonization? It's not the question that we talk about. It's just about digitalization. And EV is now contributing, and there has been more acceleration. Then came the Ukraine's and Russia's invasion in Ukraine. And as I said at the outset, 10 years ago, we're talking about smart grid, and that concept came out. For example, in Germany and Europe, they're talking about gas from Russia, and they had a very classical, outdated heating device, and also cooling system has been just introduced. But if you use heat pumps in Japan, then you can actually solve the problem immediately. So there will be probably heat pump focus that will come out in Europe. So, of course, in decarbonization, it was attracting attention, but because of Russia's invasion in Ukraine, it has been accelerated immediately. So smart factory was the first, then came EV, and then energy. And semiconductor is the central part of the whole program. And 5 years ago, I said that we are going to focus on that, semiconductors. But everybody was very critical. What about EV, and what's the energy about? But now, more recently, the market has recognized that semiconductor is important, and our activity is now attracting attention. And more specifically, in terms of technologies, if you want to know more about the market, this is just our guidance, but the digital market is the platform is the largest market. And if you also include EVs, it's about 260 trillion yen, at least 2,000 trillion. So it's half of the GDP of the US, and so it's very large. And as Mr. Nishimori said, this is going to be what is called a new industrial revolution. And then comes semiconductor and quantum technology, which is the focal point of today. But there is a fluctuation for the market of quantum technology. It's about $1 trillion. Well, it's the annual market. So we're not talking about next year, but within 20 or 30 years, it's going to double that of semiconductor at least. But compared to digital infrastructure, it's one order of magnitude smaller, but it is related to national security and economic security, so that's why it is important. So targeting at those markets, as Cabinet Office, you have to make sure that your taxpayers' money can be effectively used. Now, I'd like to wear the SIP hat on to talk about the rest of the presentation. So what we did is the cyber physical system to be applied, and it will not change. And when the companies actually use this in the field, what would be the bottleneck? What would be the hindrance? And that has to be first resolved. And that is what the SIP is about. Digital twin building or feedback control. And as for processing, in the smartphones, laser is heavily used, and so photonics is used to do the processing. And light source is necessary for that. And as for quantum technologies, the quantum computing for industrial use, not for academic use, but industrial use, that is the feature of this program. And more specifically, this is the ultimate goal image. So this may be familiar to you, but the modeling of the field devices, and then you do the modeling, and then total optimization will be done. And in the modeling and total optimization, quantum technologies can be used. And if this can be used in the device in the field, all the people use the same technology. For example, manufacturing is four times more than the vehicles, and the energy is 5 times more than the vehicles. But in case of the machines, 50 million or 100 million yen, but vehicles cost you several millions of yen, but you have to reduce. So you have to reduce the cost by 1/10. So if the market expands, then the cost is expected to decline. That is what we are assuming. So you may be wondering when I am going to talk about quantum technologies. So in the academic research institutes and corporations, starting from the basic research and how you can bridge between the basic research and business, TLR1, the NASA's technology can be used, but basic research and actual mass production technologies, the bridging function is really necessary, and that has been discussed for the past 5 years. So industry, academia, and government collaboration is necessary, and the startup companies are also necessary. Or Japanese version of Fraunhofer was pursued as well. And as I said, from the Keidan rank corporations, why there are complaints. So in the R&D field and the commercial business field, there is still a gap. So you're getting closer, but you have to get even closer in order to receive the technologies at the corporation side. So there is a Darwinian ocean, or the Death Valley, as Mr. Nishimori said. So in R&D, the peer, you have to have a network of peers and consortium. You do a lot of things in field, but in terms of outreach to the companies, you have to swim more and be more passionate. And there you have to have more people to swim from the R&D to the outreach activities. And the Cabinet Office has to take the lead. If each of the government agencies gets involved, then there's some legal restrictions, so the Cabinet Office has to take the lead. And in the middle, from the professor's perspective, this is where the companies have to take over. But the companies would say that you have to come more. The professors have to come closer. So this is a Darwinian sea. But so both have to reach out more, a little bit more, to get connected. Now, in the quantum computing, I think I have now put the Mitsubishi's hat on to give you the voices from the field. So these are the customers' voices. So they are not that manifested in the surface, but so we do understand the impact of realization, but it is not easy to use this. Or the universities and corporate R&D departments can use the project finance. So this could be the topic that they can use to solicit funding from the national government, maybe. And that's another voice. And yet another voice says that you have tried to do the digital twins and total optimization, and then realize that classic computers would not work and they need some help. So this is the voice from a president of a certain company. So to what extent you can solve the issues in the field. People are all doing this privately, but there are issues that cannot be solved in the field, so AI is really important. That's what they realized. So based on those voices, what sort of services are we going to provide? So this is the conclusion that I can give you today. So on the left, the prior national projects are targeting at R&D departments in companies. So as we participate in national projects, then we just ask the R&D department to take care. And for example, the social infrastructure or POC, proof of concept. So if there are new business development departments in corporations, they can take care. And then there is university and government. But those in the actual commercial fields in the companies. So the death valley, whether you can pass the death valley or not, you don't know. So this is something that people in the commercial field are not interested in at all. So I used to be in R&D, but I talked to the commercial business field, and they are not interested. And also SMEs. If the major companies would say that you have to come with the technologies that can work. So people are trying to swim harder in order to deliver what is commercially workable. And so what is being done is the core institutes like Kyushu, Kyoto, Hamamatsu Photonics, and others. And they are actually becoming partners. So I hope you can also become partner members. So major companies, the most immediate needs is something that we have already captured. So this can be further developed and resolved together. So more specifically, so in the quantum computing, what customers would complain about is that all three areas are going on their own disparately, like optimization, first principle calculation, machine learning. Each of the sectors is doing disparately and not working together. Because in the case of Tokyo University, first principle calculation, optimization, machine learning, Kyushu and Keio and Tokyo, they can combine all these and then deliver the services. And they have started trying on this. And this is one example of Kyoto University. So if I look back on the history, what is the most problematic in Japan is in the companies is the optimization in the field, and to what extent you can solve that with quantum computing. That has been the issue. And we have asked the quantum computing communities in the world to work on this, and they say that they cannot do this. But in the Kyoto University, there is someone who's really a genius, and he solved this issue. And then in the field, including processes, so like optimization of processing, photonics optimization, so he has solved this problem. But it's not the case that every company has such genius as part of their staff. So you just mimic that with AI so that any company can reproduce that. That's what we're trying to aim for. And on October 12th, there will be an international symposium to be held, so I hope you can also take part. And there will be simultaneously the interpretation service available, so those of you who are from overseas can participate as well. So to conclude, the target markets are digital manufacturing, automation, mobility, and energy. And more recently, there's DX, COVID-19 pandemic, a Russian invasion to Ukraine have accelerated the market movement. And quantum computing is required as an essential element by customers at the forefront of the market. So in order to meet the demand, we will establish a center of excellence that can integrate technologies as well as ecosystem supported by the Japanese government. And we're in the process of doing that. And what we are going to start commercial offering next year, and we can also provide this at a cheaper cost. So I hope you can take part in this ecosystem. Thank you for your attention.